In this video, we should be able to help you understand exactly what is required of you from the homework that is assigned for tonight. And the next slide is a review of our last lesson, so let's look at that real quickly. And in that lesson, we had first of all done a balanced chemical equation right up here. And next we did a mole ratio, a particle ratio, and found out that they were both the same as we would have for our coefficients in the balanced equation. So for instance, you would notice that the 4 as the coefficient also as a ratio is also a particle ratio. I meant to say a mole ratio. It's also a particle ratio. And the 3 from the coefficient of oxygen becomes a mole and particle ratio as well. So that's what we're trying to show in this particular part. Next, we were trying to show that the gram ratio requires you to get the molar masses, calculate the molar masses, and show those numbers as representing 4 irons. That's why you see the 4 down here when we're calculating the molar masses. And 3 oxygens, or 3 O2s that is, which is a total of 6 oxygens. Okay, so we have a total here of 6 oxygens, and I guess I better fix this. So when we take the oxygens and multiply their molar mass times the total number of oxygens represented here, which is 3 times 2, that's where the 6 comes from, we get a total mass for the left side. We also get our mole ratio, or our mass ratio, from these numbers. And then over here, we get our total molar mass for the iron Fe2O3, the iron 2 oxide, iron 2 because he has a 2+ charge. And so we got, because we had a total of 2 of those, and the total mass for one was 320, or I'm sorry, the total mass for one would have been just half of this, so that would have been 160. So what I did was I just added up these totals because that's the total of each atom that we have. See, 4, 2 times 2 irons, and 2 times 3 is 6 oxygens. So the masses on both sides wound up being the same, and we got the conservation of mass licked. Now, in the next guy, the next few slides will model how to do your homework for questions on page 357, and that's 2A through C, and 3A through B, and number 7A through C. Problems, these problems right here, 4 and 6 and 8 are really different, and they're asking you different kinds of things, not to be rendered in the way that you're going to do the next couple guys. So show the balanced equation with all the ones that we're trying to model for you. Okay, we're showing the balanced equation here with all arrows shown. Let's fix that. All arrows shown and numbered. Then show all mole ratios as demonstrated and numbered. So what in the world did we do? Well, we started with a balanced equation. Here, here, and here are coefficients, and we're going to use those as mole ratios now. The mole ratio, for instance, of, and you see I have the first thing labeled here, and it's in a particular color that matches here and here. And I've matched the color of this with these guys. And then I've matched the color of these guys with this arrow. So 1 and 2, which are these two guys, are 4 to 3, and then backwards 3 to 4. So you see these guys, these two fractions are reciprocals of each other, but each of them is a different mole ratio. This is iron to oxygen, and this is the oxygen to iron. And then our next one, 3 and 4, were these two guys, and in 3 and 4 we were going first oxygen to iron oxide. So the oxygen has the coefficient of 3, as you see here, and iron oxide, iron 2 oxide, is going to have that coefficient of 2. And then as we go backwards, the coefficients wind up being upside down, along with what substances they represent. They are in front of, is the way we should say that. Now our last two ratios are here, and they're represented by these arrows, and I see I have a little error there to fix. So yes, 5 and 6 are these two guys, and iron 2 oxide. Boy, I keep saying that wrong. Iron 2 oxide, and or iron 3. It is iron 3. Yes, it's iron 3 oxide, because the charge on the iron is 3 plus, and the charge on the oxygen is a 2 minus, and so that makes the pluses and minuses come out right. At any rate, we got a 4 to 2 here, going this way, and then we have a 2 to 4 going from here to here. And a total number of reactants and products is equal to 3 on this one, right down here, you see. And our total number of ratios are 1, 2, 3, 4, 5, 6, and that's what you see here. So let's go on to the next one, and as we add another product, in other words, we have a total of 4 reactants and products. Let's see what happens to the mole ratio. Why don't you stop the video and see if you can figure out what the mole ratio will be if, instead of having just the 3 that we have here, 1, 2, 3, we had one more here, so for a total of 4. Okay, I hope you stopped that video, and now let's go take a look and see what we get. Okay, here's our equation, and you will see we have 1, 2, 3, 4 total reactants and products. Now, I started again, this guy with this guy, and then back the other way. I know this gets confusing, and if you're taking notes, you should take them in such a way that you're using colors like I'm using. You don't have to use the exact same colors, but then the colors will really help you sort it out better. So this guy this way is a 2 to 2, and so you'll see the first and second equations both have 2 to 2, and that's the iron to the aluminum, and when we flip it and do aluminum to iron, of course they're the same. Now, the mole ratio for the second group, okay, which is right here, okay, this is a 2 to 1 ratio, 2 to 1, and then 1 to 2, which is how we get these two guys. Now, as we come over here, and we start using the blue color, the blue color is going to take us from iron to iron 3 oxide here, and that is going to be a 2 to 1 ratio. And as we go back the other way, of course, that's going to be a 1 to 2 ratio, and you'll notice the entire fractions are flipped. And with 7 and 8, we're going to have 7 and 8 be right here. Okay, this is 7 and 8, going from aluminum oxide to aluminum first, and then the other way. And then our last one is going to be what you see, oops, let's bring that back. The last one is going to be, as you see in this row, our column, you're going to see 9 with 10, which is this guy, and then 11 to 12, which is this guy. And that's how it all works out. And let's go ahead and put those numbers in. And you will see that these ratios represent these three guys here and here. Okay? So, well, that's how we do the 4, and notice instead of having, like we had before on our first one, we had this ratio. We got 3 to 6. Now on this one, we wind up having 4 products and 12 ratios. All right, there are 12 ratios there. And so instead of the 3 to 6, 3 products and reactants giving us 6 ratios, we have 4 products and reactants giving us a total of 12, which essentially we doubled. Okay, So everything gets doubled each time we add more. So that's how this is going to work. And the last thing that we have here is I'm showing you, this slide will give you the skeleton equations for each of the reactions given in the word equations. And these need to be balanced, arrows and their numbers drawn, just like we did here. Okay, up at the top of this slide, we had arrows and their numbers drawn. Let's get the pointer up here. And our pointer, if I can get that to work right. Okay, you'll see that we have arrows and the numbers. That's what I'm referring to. So these guys, each reaction given word equations, we need to balance arrows and their numbers drawn, and the mole ratios, and the mole ratios were what we did down here. Okay, all of these mole ratios have to be shown for each of those equations. So have fun. I hope this helps you understand these assignments better.